Hello everyone. Today I am talking about troubleshooting databases on Kubernetes in Cloud Native Databases conference. So who am I? I am Ege. I am living in Istanbul, Turkey, and I work in Percona on Kubernetes operators for last 5 years. Okay, so we will be talking about troubleshooting, but why we need to think about troubleshooting? Because we need to understand the failure modes that can happen on our systems, on our services, on our Kubernetes cluster, and also we need to imagine the things that can go wrong and how we can respond to them. So there is a very good technique of Stoics. Here you are seeing a quote from Seneca that they say we need to spend some time to imagine what can go wrong in our lives, because Seneca says here that the unexpectedness of the disaster is the thing that really hits hard. So if we allow ourselves to think in advance, then we can be prepared when the disaster, when the failure incident comes. So it's very famous thing to talk about, troubleshooting on Kubernetes is very hard. But why? Well, of course, it requires a different mental model because it has a very declarative nature. And we cannot just run or take imperative actions on a Kubernetes cluster. So this is one part of the problem. Second part is it has a lot of different components. There is this proxies, kubelets, control plane, API server. So all this needs to work together in a good way. They should have a good communication between them to things run healthily. But there are also some practical reasons that makes troubleshooting hard. First is images are rootless usually. And containers are immutable. So this means that you don't have a root access in a container. Also, you cannot install a tool that you need to run in case of an incident. So this makes it very hard because you are limited with the tools that comes in the Docker image itself. Second thing, so we all have a toolbox. We all have some tools that we like to use, but usually on Kubernetes they are not immediately usable. Why? Because the containers usually run in a limited set of capabilities. They are not privileged. They don't have access to the kernel. So you cannot, for example, just run strace to trace system calls. Also, there is this reconciliation loop, actually loops in a Kubernetes cluster, because there are a lot of controllers that reconcile and manage objects. And this reconciliation loops makes tweaking stuff harder. If you want to change something, just one-off for the troubleshooting, then either a controller, maybe the operator will overwrite your changes and you won't be able to do one-off stuff. Okay, let's start with the basics. First thing we need to understand is the symptom of the problem. Because with the symptoms, we won't understand the root cause immediately. But with the symptoms, at least we can isolate the problem. Is the network problem? Is the storage problem? Is the faulty configuration? So first thing should be the very basics. I know it sounds very obvious, but it's checking the logs, because I've seen many cases that people say, okay, my database posts are crashing. I have a full cluster crash, but they don't even check the logs. We need to check the logs and we need to try to isolate the error there. That error will tell us a lot of things. Also, I need to mention the importance of having a centralized logging system. Your like operator can help you to do that. For example, our like Percona operators have this like persistent logs, but it's very common to lose logs when you restart a pod. So like having a centralized logging system to collect all the logs that you can see even after the restart, then it will be very helpful. One tool I really like to use is Turn. It lets you tail logs from multiple pods, multiple containers. It works with the regular expression, so you can tail logs from a lot of different places in real time, and it makes it very easy to tail logs from the primary, the replicas, all together at the same time. Second thing is events. There is this event mechanism on Kubernetes, and they are very useful. Usually, the controllers communicate their state changes with the events. So if there's a state change or if there's a failure, if there's a problem, there will be an event. Then you will be able to monitor, see. So these are events we need to keep an eye on, especially if you have a monitoring mechanism for events. Like these are things to be alerted for. For example, crash loop backoff is like very famous, that your pod is crashing. OEM killed is there's a memory, the container goes above the memory limit and kernel kills it. The pod might be not scheduled, your PVCs might be not mounting, or maybe there's a disk pressure. That means the available storage on a Kubernetes node is below certain threshold, and it can create problems also. One important thing about events is they are persisted only for 1 hour. That means like if you have a problem and you want to check what happened before 1 hour, that you cannot see just with the kubectl get events. But there are a lot of tools to like collect events and store them somewhere. For example, Grafana Loki, Elasticsearch, and like having a system like that would help you a lot. And statuses. So on Kubernetes, all objects almost have statuses, and they like you can see if the object is considered ready or any other particular information about that object. Also, there is this very nice list of conditions. So these conditions usually contain very useful information. We are seeing a condition from our Postgres operator. So here you can see that like the stance is not created yet, and you cannot use replica create method in patron to create new replicas. So this is very good. Maybe this is expected if the class is just started, or maybe stanza cannot be created for some reason, maybe in the object storage or something. So one important thing is the observed generation here. So on Kubernetes, objects have a generation. That means, okay, this is the first version of the object, and you can see this condition happened in the first generation of the object. So you can understand, okay, this change in the object caused this condition, or maybe fixed this condition. One tool I really like to use is kubectl status. Like you can use this with all Kubernetes objects, and it gives you very good summary of a lot of things you care about. For example, this is a status for a pod, for a MongoDB pod, and you can see like its resources and the actual usage. You can see the PVC usage, and it's very handy to see all of them in a summary, and it has a lot of different flags that you can have this summary very, very long. Okay, so we did the basic troubleshooting, but sometimes you need to step in. So again, like I am assuming that you are using an operator, and Okay, operator as a software, like mimics the human operator on a Kubernetes cluster to manage databases. But sometimes a human operator needs to step in. So what can we do when we step in? So first thing is there is this infamous stateful set log. What I mean by stateful set log is like in stateful sets, there is this spatial ordering and fixed ordering of the pods. And there is a rule that if the first pod is not ready, then the second pod cannot be started. In this example, you are seeing the second pod, the RS01, is not ready. And like I have 3 replicas actually, and RS02 should be created and started. But because of the RS01, it doesn't. And there are like some cases that you want to have all of them, all pods together. So in Percona operators, we have a special file called sleep forever. If you put this file into the data dir of the particular database, then all the liveness probe, readiness probes will be disabled. So they will just run like return exit 0 and will be succeeded. Also, like if you restart the pod with this special file, the database process won't be started immediately. So you can just exec into the container and run the database process yourself. This is very handy in case of like you maybe to fix the incident or understand something, you need to have a special flag. So this is very handy for the cases like if you need to like pass a certain flag or special flag to your MySQL process, for example, then you can use this. Second thing is stopping the reconciliation. Because again, like we as human operators, like stepping in, then the software operator should pause a bit. And it's very handy because like sometimes you need to tweak something, you need to change something one-off, maybe just in a single pod or in a stateful set. And you don't want this to be overwritten by the operator. So in case of this is an example from the Postgres operator. We have this special field in our CRD. It's called unmanaged. So if you say this cluster is unmanaged, then operator will stop reconciling it. If you change a config map, a secret, a stateful set, these changes won't be overwritten by the operator. Or sometimes the operator doesn't have this kind of feature. Then you can just simply scale down the operator deployment to 0 replicas. Then it won't be running. Then you will be able to do your changes. Okay, so like for some incidents, we also need to use our toolset. We might want to use a particular tool that doesn't come in the Docker image. So what can we do then? So we have a very good feature since Kubernetes 1.25 is ephemeral containers, and it is also used for this debug command. So when I run a kubectl debug, it attaches an ephemeral container in a pod. So this is very useful to have your own troubleshooting image or just like use a Debian image with root access. Then you can install stuff and check things. So 2 things are very important here. First one is the share processes. With share processes true, our debug container will be able to see all the processes in that particular pod. And second thing is profile sysadmin. So here I am telling that, okay, this debug container should be privileged. By privileged, I mean it should have access to the kernel. This is usually very useful, but also dangerous thing. But because like if you have access to kernel, you can affect all the Kubernetes worker node. Also, like it is a like how can I say? It's a attack vector. So it's a security concern also. So usually it's very common that like Kubernetes admins make it hard to run privileged containers, even disable it for a lot of users. So having this guardrail is usually very good, but if you have a guardrail, there should be a very clear process to how to bypass it in case of an incident. You can also create a debug pod on a particular Kubernetes worker node. This is very useful if you want to debug something on the worker node level. Because the root file system will be mounted to the container. Then you will be able to see the logs, for example, or check the processes there. This might be very helpful also. So with debug containers, you can run Percona toolkit, the famous collection used by mostly our support engineers, but like the collection is very helpful in many cases. You can run strace if you are running like a privileged container. You can run strace to trace system calls. You can run TCP dump to capture network packets. You can run IOStat to monitor IO activity. So like the sky is the limit. And even you can do crazy stuff. For example, here this is an example from our PXC operator. So I want to run Vim in that particular database pod, but Vim is not installed. And I don't have a root. The container file system is read-only. So how can I install Vim? So I am attaching a debug container. And in the debug container, what I will do is I will download the RPM for Vim. I will copy this RPM to the TMP directory of the PXC container. So I will run nsenter. Then in that shell, I will run RPM. So in the end, in the PXC container, I can run Vim. This is when I first saw this. I thought it's crazy, but it is very, very useful in some cases, because I remember like we figured this out. Our support engineers like actually figured this out, and like they were trying to run heap track to investigate and debug a memory leak in MySQLD. But heap track needed to be installed near the MySQLD. So with a lot of back and forth, like we figured this out, and like we installed heap track, and it was a victorious moment. So yeah, in summary, like experimenting this kind of stuff before like a problem happens, an incident happens, we are in the middle of downtime, would help you be prepared. Like making all these experiments and trying to understand all these failure modes and how we can respond when we have the luxury to do so is much better than like trying to figure all this out in the middle of downtime and people are screaming at us, because like things break, and like if something can break, it will eventually break. So this is the end of my presentation, but before I go, I want to mention one thing. Percona Live is back. So we are doing a Percona Live in this May in the Bay Area. It will be a very, very like good conference, and the call for papers is still open, so you can also submit talks, submit proposals, and see you there. So you can always reach out to us. Like we are as operators team in Percona, we are monitoring our community forum and like respond topics there. So if you have a question, if you want to discuss something, you can always create a topic there. If you have a problem or again a question, you can create issue on GitHub. We are like checking them daily. And all your contributions, all your pull requests are welcome. We are very happy to see like contributors come and like send pull requests to us. So like they are very welcome.